Okay, so we ended the last video by seeing that we have one critical value from the first derivative, which was right here. Your first derivative being a rational function. First derivative undefined, I got x equals -1 to be a critical value. And then when I tried the first derivative set equal to 0, I saw that there's no value of x that will make that first derivative set equal to 0. So that just means there's no more critical values. So now I just am looking for, do I have any max or mins? Now I remember that at -1 from the original, I have an asymptote there. But I pick a number, first derivative test, I take a number to the left, so I'll take -2, and I'll plug it into the first derivative. So if I have dy dx is equal to 3 over x plus 1 squared. Now think about it. It doesn't matter what I plug in for x, because if I square it, it's always going to be positive. So this will always be a positive over positive. So it's going to be positive here, and if I did 0, it's also going to be positive. So I definitely have no max or min because I don't even have a sign change. However, let's just say this was plus and this was minus. You have to remember, if this was an asymptote, that means there's no max there, all right? So, or min, because there's no point. But you would figure that out if you tried to plug it into the original to find that y coordinate and it didn't exist. So for this problem, there was no max and / no min. Okay, so the last part of this worksheet was to find intervals of concavity and points of inflection. So at this point, I'm hoping that you guys are getting comfortable that intervals of concavity or points of inflection are coming off of the second derivative. I actually want to go back to this problem for 5 seconds because yes, there's no max or there's no min, but what else do I get from the first derivative? Because I know I need the first derivative for max and mins, right? I also get intervals of increase and decrease. So since I see this as plus and plus, I know this function, y, is increasing from -infinity to -1. And in this case, it's an asymptote, so I cannot include it, -1 to positive infinity. Okay, so just remember first derivative, yes, that's how I get my max and mins, but it also tells me if I have any intervals of increase or decrease. Okay, so going back to the last part of this worksheet where they're asking me for intervals of concavity, points of inflection, that's coming off of the second derivative. So I'm not going to do all this work. I already found my first derivative to be dy dx is equal to 3 over x plus 1 squared. And as I said before, I know that asymptotes are hereditary. So I know on my second derivative test, I already know -1 is going to be a critical value of an asymptote. But let's get to work. Okay, if I look at this, I go, oh, do I have to do the quotient rule to take the second derivative? And I don't. And I honestly would suggest not to. Only use the quotient rule when both the numerator and the denominator have variables. To get to the first derivative, I had to because the numerator and the denominator had variables. Here, I'm just going to rewrite the first derivative as 3, and I'm going to bring up this whole binomial and apply a -2 exponent. And so now I'm ready to take the derivative using chain rule. So here comes my second derivative is equal to the chain rule is the derivative of the outside. So it's -6, rewrite the inside, drop this by 1. That's the derivative of the outside times the derivative of the inside, which just happens to be 1. So my second derivative, written without a negative exponent, is -6 over x plus 1 cubed. Okay, so now I'm looking for any critical values. Critical values are when the second derivative is undefined or the second derivative is equal to 0. So let's talk about being undefined. I see I have a variable in the denominator, and I go ahead and I say, okay, that happens when x plus 1 cubed is equal to 0. Cube root, x plus 1 is equal to 0. So again, I get that -1 to be that value that makes it undefined. We already knew that, okay? So just in case you forget, organically you'll figure it out when you take the second derivative. And I always do like an asymptote on that value just to be reminded that that is an undefined value. Okay, now let me see, is the second derivative any values when the second derivative equals to 0? So if I put -6 over x plus 1, because that's the second derivative, I said it equals 0. Again, I cross multiply and I get -6 is equal to 0. Well, that's not true. There is no value of x that will make that second derivative equal to 0, which means that there are no more critical values. So now I'm just going to do a sign test. So when I go ahead and do a sign test, I'm doing a sign test into the second derivative. If I plug in a -2, so this would be a -6 over -2 plus 1 is a -1 cubed is going to be a negative. So so it's going to be a negative. So you have a negative over a negative, which makes it a positive. That's when I plugged in here the second derivative for -2. So I know this is plus. Now, if I go ahead and try the second derivative for when x is 0, I get -6 over 0 plus 1 cubed, which is just a negative on top and a positive on the bottom, which is a negative. So that means this is negative. So here I can say, yes, I have an interval of concave up. The interval of concave up is from -infinity to -1, not inclusive. And then the interval of concave, and I just write concave down as CCD, concave up as CCU, or you can just, just so you guys start getting comfortable, that's how we do it in AP Calc. So this is concave down is from -1 to positive infinity. All right, so now do I have a point of inflection? All right, so point of inflection is when I have a critical value and a sign change at the second derivative. I have a critical value. Some of you might be in the zone and go, yeah, I have a point of inflection because it's -1 is a critical value and I have a sign change, except I know that -1 was not, was undefined. Now let's say you forgot and you're thinking, oh yeah, I do have this at -1. Well, remember, to find the y coordinate, you have to always plug back into the original. So if I went to the original function of 2x minus 1 over x plus 1, and I plug in that x value of -1, I get a -3 over 0, which is undefined. So I go, oh, there is no point. I remember now, there is no point. So there is no point of inflection because that sign change is occurring at an x value where the original function is undefined. So you will be practicing the second question, but I'm continuing with a video on being working with the first derivative. So I'm going to pause this one and start a